is on SSH. Best kept secrets is what I called it. So a little disclaimer, you know, like I'm not claiming that I'm some pro with SSH. I just am a Linux user. I run Linux on a MacBook Pro. I'm a developer. And I just want to share some stuff that I've learned about SSH. And in the spirit of MinneBar, this is an open conversation. So I fully expect somebody in the back who's going to know something about this that I don't, or that we don't. So feel free to speak up and contribute. So, all right. So who am I? I'm Colin Harrington. I'm a software consultant at Object Partners. I build stuff. I've been rocking with a Grails framework for years now. You can find me on Twitter, Colin Harrington, Google+, colinharrington.net. Hit me up and say hi. So, got to go through the basics, right? SSH. Give you a second to read that. So we're talking about a remote shell that communication is cryptographically safe going from one computer to another here. So that's the tool we're talking about. So yeah. I don't think it has to be, but I think it's a protocol to allow you to go over an insecure network and not let any secrets into hands of, there is an overhead to SSH, right? It's the whole encryption and the whole key passing, all that stuff. So you're going to get lower throughput because there's going to be more data going through your pipe, right? Minus compression, whatever. So if you are on a safe network, it's, you know, you don't necessarily have to secure that. You can secure it in other means, basically. One of the keys of SSH is that we use public key cryptography to handle the communication back and forth. You know, if you know something about cryptography, there's asymmetric and symmetric encryption, right? So the whole idea that there's a secret key that only the two parties talking know about, and they can talk between each other in an open room, and nobody else knows what they're talking about, right? So public key cryptography is another generation above that, which is using public and private keys, and we'll get into that in a second. So let's just, I'm going to clean some things up here. All right. So let's just SSH. I've got, I brought a couple toys here. I brought the laptop I'm presenting on. This is the E1705, the IP address up here, and then another laptop over here that I'm communicating to. Also brought a little router, you know. Nobody, don't hack it unless you can show me what you did. So. What we're going to be doing is communicating between the two boxes and just showing some things here. So, so the SSH command, you give it a user at an IP address. And I'm on this box, and I'm going to go to that box. So 192.168.1D8. The first thing you see is, whoa, we don't know who this person is, right? The authenticity of host, blah, 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 can't be established. They have a fingerprint of blah, blah, blah. Are you sure you want to continue, right? This is like confirming, is this who you expect it to be? Is this their signature? So this is important when you were getting into like man-in-the-middle attacks where if somebody's in the middle and they pass data through you, you want to confirm who you're actually talking to and verify this host. So, I'm going to say yes here because I trust that I'm on my own little network and nobody's hacked me yet. Ooh. We'll get to that too. And then boom, I'm logged in here. So if I go host name, obviously you can tell by the prompt there, now I'm logged into a remote shell on this other computer, right? Whereas this right here, this is a new shell, is my local computer. Yeah. Right. STD. So that was, I have got a remote connection. This computer happens to be sitting right here. It could be across the world. It could be in Shanghai. It could be Amazon Compute Cloud and some random server that's virtualized somewhere else, right? So you're peer-to-peer. You don't necessarily own and trust the whole network, but now I have a secure channel to do stuff here. So I can feel safe about, you know, sudo blah, 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 and using sensitive passwords and that type of thing. Basic example of SSH. So we'll just spend a minute talking about history. 1995, a guy named, no, I won't pronounce that. Does anyone know how to pronounce that? Give it a shot, nobody? All right. All right, well, let's not murder his name. This was a guy at Helsinki University. He actually designed SSH in response to some password sniffing attacks that were going on at his campus, right? So in 1995, he did this, and it was designed to replace login, telnet, and RSH, right? So telnet, there's no security at all. It's just a raw socket connection back and forth and do whatever you want. If you've ever opened a telnet, you know, session to like an HTTP server and do the protocol manually, don't screw it up, right? And then our login and RSH, it would be remote shell, and then there's you know, cryptography going there, but they're vulnerable to other issues there. What he did was all released open source. You know, he gave it out for his freeware because he thought it was a big deal to give this stuff out free. And the original version that we're talking about, we call now SSH-1. That's SSH version 1. So, 95, December of that year, he founded a company called SSH Communication Security. But it's a little disappointing that, well, the guy had to support himself, I guess. So he, more and more of his work became more increasingly proprietary, and he started, you know, making a little bit of money on it to support himself. And there's nothing wrong with that, but that's just the way it went. So version 1 was implemented, so he designed it in 95, and then it was first implemented in 1995, in July of 1995. We call it SSH-1. Yeah, creation was prompted by a password sniffing attack at his university. It's fun. The old Wild West days in 95, yeah. So, SSH version 1, right? It's pwned, it's vulnerable to certain attacks. 1998, there was a SSH insertion attack where the checksums that would be used to validate the content of what's going through, there was a way to insert extra data into it and hence, you know, break that protocol, right? Insert new commands, like what? Like reset password, like, you know, anything they can do there. It ended up being like a weak CRC, 32 hash check. 2001, there's some more vulnerabilities dealing with data integrity, tagging more data at the end of certain blocks, and client authentication, where you could fake the user that you're connecting to the wrong host. So SSH-1 has design flaws. We know it. That's all out there. Don't use it. Yeah. Oh, another side note. When the first vulnerability, the SSH insertion attack came out, there were add-ons that people wrote to protect against this and do like double checks on that. Well, yeah, most of those had like buffer overflow issues too, so they didn't make it any better. So, the unicorn version 1.99. So this version is to indicate, hey, that SSH server can support version 1 or version 2, right? There is no version 199. That's just the magic number to indicate that you can support both. So version 2X has better security and more features, right? So this is on a Linux box. If you're using Debian or whatever, you can aptitude install or sudo apt-get the Open SSH server, right? So Open SSH is the I'm already there. Awesome. So Open SSH is the open standards version, right? So that proprietary version, there was another crew that created OSSH, and then the BSD folks came along and made a completely open and free version, and that's what became OpenSSH back in the day. So it's a suite of tools that replace, login. It's a SSH basically, focused on SSH2. So things like SSH was replacing Telnet, and RCP or SCP was replacing RCP. These standard Linux commands that we had. It also included, SSHD and a bunch of tools to do like an agent and key signing and all this stuff. That's how you install it. There's a lot of, why is that? Okay, so one of the keys to SSH2 is it's using this Diffie-Hellman key exchange. Does anyone know what that's about? Know a little bit of something? So public key, private key. It's the whole issue of being able to communicate in an open room. If I want to send a secret to somebody way in the back and I want to say it openly in this open room and have nobody else understand it, how do I do that? Like a naive way would be like, oh, we both have this shared secret where we both speak Swahili and nobody else does. Well, that's nice until somebody else learns Swahili, right? So there's a whole protocol of having both a public key and private key and combining some stuff mathematically and being able to send data across the wire so that nobody is going to figure it out. I don't even know his private key, he doesn't know mine. We can just communicate because we've established this protocol of a shared secret. So, yeah. Yes. Exactly. So what you're saying is you have a client and server. If I know, if the client knows the server's public key, it can encrypt something with that public key that only the server knows how to decrypt. And that's the trust that we have. And then the server can send the response that only the client knows how to decrypt without ever sharing that private key, right? So Diffie-Hellman, that was a really big deal in establishing secure communications. You ever see the movie Sneakers? Remember the code breaker, right? This is the like you can't touch this because it's secure type of thing. So here, this uses an example of colors, right? Alice and Bob, you know these guys? Alice and Bob, you ever heard of these guys? So two people. They have a common paint. They've got their secret colors, and they're able to pass back and forth, and not necessarily share their secret colors, but through mathematical, prime numbers and mathematically be able to convert things so that only one and the other can see it. All right, theory. You could spend forever, diving into this and going into the mathematics and blah blah blah. Let's not go there. So, SSH, right? You've got a couple different methods of authentication. First one being passwords, right? Like what I just showed you. I logged in, it asked me like, hey, do you trust this guy? And then it asked me for the password, that user's password, right? So that's a user password-based authentication. The next level would be, it's still user-based, but it would be using the public key and private key encryption. So instead of like a password that I have to remember and type and kind of gets sent over securely, this is a shared big long 2048, 49, 6, well, however big key that I'm not going to type in, Wouldn't that be painful to type in, you know, a public key every time? How about this? Yeah, am I gonna type that public key in every time? Yeah, that would hurt. Oh crap, I missed a letter. Right? Oh, that was a slash. That was a forward slash, not a backslash. Whoops. You know. Right. So that's one mechanism. And then another mechanism, there's a whole like infrastructure for third-party authentication on the server and even on the client that you can use. You can use like the Google Authenticator even, if you want to. There's stuff out there to do that. So this GSS API, that's more important on the server if like you're logging into Active Directory or a company, you know, bigger infrastructure. I typically try to stay away from some of those. But, yeah. And SSH, yeah, it's configurable as PAM, right? The pluggable authentication module. So that's a big Linux, Unix thing. So. All right. So let's make a public-private key. All right. So the command for that is SSH Key Gen. And you don't have to necessarily specify anything to it. It will ask you a series of questions. So this is generating a new public and private RSA key pair. There's RSA, DSA, and then an elliptical curve, you know, whatever. The different mechanisms of generating these keys. And that may be important at some point. Things like that Java SSH implementation doesn't support some of the elliptical curve, you know, encodings, and you get into some details occasionally there. So this is asking me, where do I want to save this key? By default, it's this ID RSA. What do you think? Let's go. Let's call it MinneBar. Passphrase? Yeah, let's skip it for now. No such file directory. Great. Let's not do MinneBar. Okay. It doesn't? Is that what it was? Okay. Well, then let's fix that. Of course, you guys love watching me type. No passphrase. So, I specified the location. It has been saved in there. There's the public key, right, saved here. The key fingerprint is there. It also saved a private key at MinneBar. The key's fingerprint, you know, and the random art image. So let's go look at it. So let's look at the public key first. Maybe this would be easier. Okay, so pretty simple. SSH, RSA, bunch of stuff for what host? Pretty simple. It's a public key. Now let's look at the other one. Of course, I'm going to delete it. And this is the end of the private key. So this is this big, long private key that you can't do anything with, and you don't see the whole thing, so it really doesn't matter. Boom, that's where it is. The other thing I wanted to show you here is the permissions here are important in this directory. The SSH will bomb out if your private key is permissions are too loose. Like if anyone can read your private key, it assumes, yeah, that's a bad thing, right? You might be compromised. So you remember when Gandalf, the Lord of the Rings fans, anyone? Okay, we're a room full of geeks. No, back there? Really? Okay, well, you're outnumbered. Deal with it. Good job, Will. So remember that scene when Gandalf comes back and scoops up the ring with on the floor and hands it to Frodo. What does he say? Keep it secret, keep it safe, and runs off and takes off, right? You know. So keep your private keys secret. Put it on an encrypted drive if you have to. You know, if I steal your laptop, it's not too hard to rip out a hard drive and find those files, right? Linux permissions don't matter at that point, so you might want to look into, you know, don't just trust, oh, I'm using a public-private key, then I'm fine. Well, if you, hey, email somebody your private key, yeah, that's probably a bad idea. Hence, that would also be a bad idea. But then you just generate a new one, right, and revoke your old one. So, yeah. Private key, keep it that way, right? Yes, exactly. So that passphrase thing that we just went through, that I just didn't enter a passphrase, that's what that whole thing is supposed to be, right? So that passphrase unlocks the private key. Not that that couldn't be cracked over a certain period of time, but that's another layer of security. Question? Yes, we are gonna do exactly that. So, right. So yeah, this is my authorized keys file. We'll get to that. So if I tried to do something like, let's try to SSH to that same place that I did before. And let's use the identity file. SSH MinneBar .pub, I think. Then it's going to use this key. So you can specify with that -I which identity file you want to use when connecting to things. So you can have multiple identities. You can connect as different users. You can manage those in a fun way. So it still asks me for my password. That's fun. Yay, and I'm in. Woohoo! So let's exit so I'm into this other machine over here, right? And let me exit out of that. So what you were saying is, well, we've generated a public key. I've shown you how to use it, but what if I still had to enter the user's password to log in, right? So I was using that key, but that key is not associated with a user, right? So you're not limited there. So if I wanted to use just the key to log into this other user, this other machine, how would I get it from one machine to another? SCP? Good example. Does it have to be SCP? Why? Why? It's a public key. You don't necessarily care if anyone sees it, right? The whole point of it is it's public information. People, right. So if they compromise your network anyway, though, that's clear. That public key gets passed over in the clear in the first place. So the whole idea is you can email it, you can put it on a web server, you can post it on Facebook, you can do whatever you want with it, right? Because your public key is public information. Nobody really gets anything except the ability to encrypt something with it that only you can read, right? So that's public information. So SCP would be one way just to copy it over, FTP, or just set up a web server and copy it over. So you were getting into adding it to, so let's SCP it over there. So SCP, I believe it's file name, bar.pub to 2.16. Yep. Thank you. And it's 28, right? And then I want to put it on, I'm just going to put it in this MinneBar folder. Still have to enter my password. Now I put it over there. So now let's log into that other box again and check it out. All right, this MinneBar.pub. Oh, that looks awesome. So it's over there. It's copied over there. That's a public key. So I would have to add this public key to this authorized in the .ssh folder in your home folder, right? So let's go there. And this is on my other machine over here, right? I'm SSH'd into this other machine. .ssh. And if I open up the authorized keys, I guess I've only got one of them there. I think I nuked it recently. So I could add a line right here. I could use cat. I could pipe it in there. I could copy paste. I could just add it here. If this file doesn't exist, you have to set up the authorized keys with very strict permissions as well, right? So you have to be careful about that. I'm a little too lazy to copy all this stuff, so there's a tool called Ssh Copy Id that does this for you, right? So I'm going to go ahead and use that quick. All right, SSH Copy ID, and it's going to be, what's that? Yes, it is. Sometimes it was a user script at one point, and it got included in some of those. Ubuntu, you might have to add another package with it, so it might be, depends on your distro, but it's easily accessible if you have any sort of package manager. 168 at 4.28. We'll get done copying this stuff. Yeah, I don't want to type all that. That's right. I still have to enter my password one more time. And boom. Man, that's really... can you guys still see that? All right. So now it is added this public key to the SSH authorized keys. It says to go check it out, and now I can just type SSH blah, 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 and it will connect automatically without using a password. So let's try that. Boom, no password, because it used that identity file that I already set up, right? Yeah. All right. So if you've got like 10, 20 machines, this is really handy. If you've got like a key you want to copy over in a bunch of places, rather than entering in 5 different passwords for 5 different machines and trying to remember them, and then there's the other coworker who says, forget it, let me just write them down on that piece of paper and stick it by the monitor. That type of security, yeah. You might want to look into managing public-private keys. That might be a little bit better. The downside is if anything happens to that key, you do have to revoke that and remove it from the authorized users, and then you're done. Question? Yes. Great question. Let's generate another one. All right, where's the Key Gen? Key Gen. Let's go. SSH, MinneBar, passphrase. Enter a passphrase. What's that? Yeah, I'm going to go ahead and ignore that. Oh, it needs to be more than 4 characters. Oh my gosh. MinneBar, that would be a good one. Passphrase. Okay, there we go. So I created another one called MinneBar-passphrase. So now let's go and let's copy MinneBar-passphrase to to call in at whatever that IP address is, right, to my other machine. And that just did it. It didn't. Oh, now oh yeah, it copied the authentication. Now if I go SSH, I want to be done typing these IP addresses. We'll get there. So now I don't have to. Now I've got this passphrase. And what this is going to do is it's going to like, hey, we can't use this public or private key until you give us the correct passphrase. Which means that if you got a hold of this private key, you couldn't do much with it without the passphrase. You could brute force it all day long. You could figure that out and get to that. That's probably not too hard, but it would at least give you a window of opportunity that if you had a laptop stolen, you could have a small enough window that you can go talk to your server admins and get stuff cleaned up. We'll get there. That's the next step. That's a good question. Yes, but how does that SSH command know to use the MinneBar passphrase one versus not? It might be. Well, I use the same one, so you're right. You're right. So probably, I think it is using the default one, and this is the first time I've used the default one after removing some stuff. I think I might have overwritten the first one. So I entered my passphrase. So now if I exit out of that and try it again, I don't have to enter my passphrase again until I log out of this computer. So there's an SSH agent that kind of like keeps that key alive, you know, keeps that authorization alive so that you don't have to re-enter your passphrase. So this SSH agent that I've got going on here, that's this thing right here. This agent is running in the background, keeping a hold of my public-private keys, or keeping a hold of the authorization of your passphrase. So if I kill that, it would ask me for the passphrase again and restart it. Yeah. Question, Sean? Yeah. Okay. Whoa. Okay. All right. Long story short, SSH config. So I'm sick of typing names. I'm sick of typing all these like command line parameters. You can set all that stuff up in SSH config. Let's go look at it now. No. So I have two hosts set up. The Lail host, the IP address, which user. So I don't have to type the user again. It uses your local username by default if I didn't specify anything anyway. But if this was something else, you could specify the user. And then there's a whole bunch of other things that you can set up in here. So now I set up my phone as well. So if my phone is on wireless, like if I go hook it up, here we go. You're telling the FCC what, that I jailbroke my iPhone and that, yeah, good for you. So now I can just type in just the alias host name, right? I can change it to 1 letter, 2 letters, and alias the heck out of it. So anyway, jailbroken phones, you can put SSH on this, routers, computers, Raspberry Pi. If you're running some sort of random stuff, there's SSHs on all sorts of stuff, so it comes in really handy. All right, there's a bunch of stuff in SSH config to look at. Let's see, one of them that I was gonna show you that I will skip for now is X11 Forwarding, where you can actually you can run an application on this machine and forward the display to this machine. So I can run programs that are on this machine and forward it over here. It's really useful for debugging. You're running a server. You can install X and forward that, you know, and run some GUI tools and do all that awesomeness. Oh! Yes, I love it. All right, so SSH phone. So I can SSH my phone. What was this? Yeah, that. Good. Okay, so the next thing I want to show is where's the file system stuff? All right. That's awesome. The next thing I want to show, let's take a picture here. MinneBar. Let's connect to my phone. Yeah, let's go for it. Why not? Go full screen. Oh, come on. Space. The other way. Let's copy this to the desktop. I think that's the right one. And yay, I just copied this picture that I took over SSH to my, oh, that looks awesome too. To my local desktop, right? Woohoo! Good smile there, John. So you can do so SSH file transfers, right? You can connect over SSH and transfer files. Linux is awesome. I absolutely love this. So I can fire up my home folder and connect to a server, right? So I can connect over SSH to, let me just type in my alias, and boom. I am accessing the hard drive on this computer over SSH. So that's really useful if you're doing file transfers or anything else. I mean, there, let's fire up a little clip of a movie. All right, so so that's the folder that we were looking at, so file transfers. You can also do proxying. So you can actually send network traffic from this box and have it come out on this side, right? So if you are on like a corporate firewall and you want to set up a proxy and access stuff, you can set up a local proxy so that you forward everything to the other machine. You can do things like local IP forwarding or port forwarding, right? So you can open a port remotely on here that comes out on the other side, and then you can do the reverse. You can open up a port over here that comes out over here. So you can effectively tunnel. You ever see those movies where they tunnel and they track from dot to dot to dot and they're tracing, you know, like a big, huge theme? Yeah, well, that's the type of stuff you have to do when you're on a corporate firewall to get past that, right? Anyone use Twilio? Yep, the talk over there. So Twilio. Part of Twilio is Twilio makes a request back to your server. Well, that's not very awesome when you don't have a mechanism to get back to your server, right? So sometimes you need to set up a tunnel and a port that is tunneled through SSH back to your own local machine. So you can use these tools to set this up. So let's see. Here's the example where Twilio servers will make a request, an HTTP request, to a port on a local router to an SSH server, and you have this SSH tunnel back to your development application, right? So you can set up really complex graphs and have network communications go all over the place and come from different areas, and it's really quite interesting what you can do with this. I mean, so I think I'm about out of time. Are there any questions at this point? Should we do some of this? Yeah? All right, well, let's take a minute and do that. So, all right, let's log out of my phone. So SSH, I can give it, I want to do a dynamic localhost port 2222, and then let's go to this other machine. Awesome. So I open up this SSH connection, and now I'm going to configure my browser to preferences to use a local SOCKS proxy, right? Before I do that, I want to show you something quick. Wrote a PHP script that just tells you what IP address you're coming from. Right now, I'm going to a local Apache server here. Once I edit preferences and change the network, we'll see that if I refresh this, where did that go? Yes. If I open, obviously localhost is going to resolve to localhost. If I open the web browser to this IP address, it's telling me that it's coming from the other machine right here, right? So the network traffic is going over the SSH pipe from here and making their request from this angle. So that's a dynamic proxy. That was the -D that I used there. You could also use a local port. So that would open a port on this machine that would get forwarded to a remote remote host and port over here. So it's really useful if you're like stuff behind firewalls, EC2 when you need to get into a database that's only accessible in certain networks, that type of thing. Or you could do the reverse where you have a remote port forwarded to a local endpoint. Question? Yeah. Yes, that's one of the great reasons. It's locked down. You can get in through SSH. If you're a corporate, firewall guy, yeah, you shouldn't have been here in the first place. Because you can put it on port 80, and nobody can really intercept those streams. And it opens a local port on your machine. That port is available for the machine, so it's port security at that point and dealing with that whole realm. So, thank you.